Hello guys, how are you? We are back here again with a very new session of our ongoing crash course and today's topic is electrostats. So आज से हम 12th start करने वाले हैं and I suppose आप सभी ने 11th के सारे previous lectures देख लिए होंगे. But first, just tell me whether I am audible and visible to all of you. आप मुझे chat में बताओ if I am clearly audible, visible so that we can proceed with the session and बहुत amazing session होने वाला है. इलेक्ट्रोस्टैट्स का फर्स्ट पार्ट होने वाला है आज एंड इसका सेकेंड पार्ट हमारे नेक्स्ट सेशन में कवर होगा. सो आज हम बात करेंगे चार्जेस, इलेक्ट्रिक फील्ड, कूलम लॉ एंड डाइपोल एंड बहुत सारी इंपॉर्टेंट चीज़ों के बारे में वील हैव अ डिस्कशन. ओके, एंड फर्स्ट एंड द फोरमोस्ट, सी आप नीट के एस्पिरेंट हो, जेई के एस्पिरेंट हो, हमेशा ऑलवेज रिमेंबर 12th का वेटेज इन द एग्जाम इज ऑलवेज हायर देन द 11th वेटेज. ठीक है, एक नॉर्मल ट्रेंड था 60-40 का बट इट हैज बीन चेंज. बट स्टिल इन ऑल द एग्जाम्स इट हैज ऑलवेज बीन सीन जो वेटेज 12th के सब्जेक्ट्स और टॉपिक्स का होता है, वेदर इट बी फिजिक्स, केमिस्ट्री और मैथ्स, वो हमेशा ही ज़्यादा होता है 11th से. एंड 11th के कॉन्सेप्ट्स यूज करके हो सकता है कि आपको इलेक्ट्रोस्टैट्स के क्वेश्चंस दिए जाएं या फिर ऑप्टिक्स में भी कुछ एलिमेंट आ जाए आपका मैकेनिक्स या किसी और पोर्शन का, या फिर मॉडर्न फिजिक्स में भी आ जाए. सो 11th के कॉन्सेप्ट्स यूज हो सकते हैं बट क्वेश्चन का जो क्रक्स रहेगा दैट विल श्योरली बी ऑफ क्लास 12th एंड आप बहुत सारे ऐसे क्वेश्चंस में देखोगे. एंड दिस इज द रीजन आई वांट यू ऑल to focus very very clearly in this portion which is going to go live today itself. आज से जो सेशंस चालू होंगे फिजिक्स के जो कि 12th के हैं, उसमें आप सभी को बहुत अटेंशन के साथ सारे सेशंस देखने हैं. साथ ही साथ यहाँ पे कूपन कोड अभी डिस्प्ले हो जाएगा एंड वो कूपन कोड को यूज करके आप ऐप पे जाकर टेस्ट आईडी के थ्रू टेस्ट दे सकते हो. डू गिव द टेस्ट एंड डू एनालाइज द रिजल्ट बिकॉज दैट इज सीरियसली गोइंग टू बेनिफिट यू इन सो मेनी वेज यू इवन डोंट नो. ठीक है, बिकॉज द एनालिसिस रिपोर्ट of the tests are so comprehensive in itself. We have just tried our best कि हम हर एक पैरामीटर पे आपको एक insight दें, whether what's your level, how much time you're taking and in what areas you can improve and what all key factors you need to implement, आपके key skills क्या हैं, आप किस क्वेश्चन में कितना टाइम दे रहे हो, एंड ये बहुत सारी चीज़ें जो कि एक स्टूडेंट को मिलती नहीं है. दे नेवर गेट टू नो कि दीज आर द प्रॉब्लम्स एंड दीज आर द एसेट्स ऑफ माइंड एंड दोज थिंग्स शुड बी नोन वेरी क्लियरली व्हेन आई एम अबाउट टू गिव एन एग्जाम लाइक जेई. ओके, एंड कुमार, हेलो, हाउ आर यू? आई एम वेरी गुड. एंड जितने भी आप लोग यार जल्दी आ जाओ अभी फॉर द नेक्स्ट 2 आवर्स. आई वॉन्ट ऑल योर अटेंशन टूवर्ड्स द स्क्रीन. हम इलेक्ट्रोस्टैट्स कंप्लीट कर देंगे. इसका फर्स्ट पार्ट आज है, सेकेंड पार्ट नेक्स्ट डेट में होगा. बाय द एंड ऑफ दिस सेशन आई विल बी गिविंग यू द नेक्स्ट डेट when the second part of electrostats is going to occur. Meanwhile I expect आप equally physics, chemistry, maths तीनों के lectures देख रहे होगे and thanks a lot for your support guys. We need your support more and you have literally given us so much of support. आप हमारे views देखते हो, आप comments भी करो. We actually give notice to your comments as well. आप जो comments करते हो we'll try our best कि हम उन्हें implement कर पाएँ अपने ongoing sessions में. साथ ही साथ आपको और जो services दे पाएँ जिससे कि आपकी ongoing preparation और ज़्यादा streamline हो पाए so that you can clear that exam. So your suggestions are highly valuable and they are always welcome to us and we are for you guys only. We are here जिससे कि आप एग्ज़ाम बहुत अच्छे से क्रैक कर पाओ. आपको जो भी प्रॉब्लम्स फेस करते हो नॉर्मल लेवल पे एक स्टूडेंट के पॉइंट ऑफ व्यू से, वो सारी दूर हो जाएं. एंड यस, द एम इज ऑलवेज दैट बुल्स आई एंड दैट बुल्स आई इज व्हाट? It's that cracking of JEE Main. Okay, and let's start this session, but let me give you a brief about myself. My name is Adarsh Rai and I'm a physics faculty over here in Extramarks. I have a rich experience of around 6 years. So from past 6 years after graduating from NIT Bhopal, I have been mentoring and helping students ace the exam of JEE Main, and I have so many students of mine which have graduated from so many IITs and NITs. They might be viewing this series as well right now. If I talk about Extramarks, so Extramarks is one of the leading brands in JEE and NEET preparation for students. We have ensured कि हमारा मटेरियल बेस्ट हो, हमारा एजुकेशन बेस्ट हो एंड हमारी सर्विसेज ऐसे ओरिएंट हो जिससे कि एग्ज़ाम क्रैक हो. and this is the reason हम अभी तक we are not boasting much, but still out of 7 candidates 1 student has been selected in JEE Main, and we never say this is the max which we want to receive or we want to achieve. Obviously we are going to upscale it next year. When you will be viewing this kind of a crash course, आप definitely इस figure में improvement देखोगे. And if I talk about our application, then the application is actually very brilliant. The content, it has been so much thinked upon that the content in the app is very much in line with what JEE Main has been asking from past so many years. See, the strategy has changed. So many types of, even NEET has now become difficult. Last year physics NEET paper was tough. Even JEE Main में कुछ portions tough आ रहे हैं, कुछ tough easy आ रहे हैं. So there are so many variations occurring with time, right? And students need to grasp those variations, because studying is one thing, and studying in accordance with what has been asked. Because just tell me very clearly, your main aim is to clear the exam, right? You have studied. देखो नॉर्मल कॉन्सेप्ट्स तो हम एनसीईआरटी पढ़ के भी समझ सकते हैं, बट टू क्रैक दैट एग्जाम हमें एनसीईआरटी के साथ साथ कुछ क्वेश्चंस और बहुत स्टैंडर्ड वेराइटीज, अलग अलग कॉन्सेप्ट्स देखना और समझना जरूरी है. देन ओनली वी कैन क्रैक दोज कोड्स, वी कैन क्रैक दोज डेटा. एंड ये जो वेरिएशंस है, दीज आर नॉट स्टैटिक, दे ऑलवेज चेंज, दे आर डायनेमिक इन नेचर. सो उन वेरिएशंस के साथ साथ ऐप इज द बेस्ट प्लेटफॉर्म जहाँ पे हम चेंज ला सकते हैं. एंड ऐप पे आपको ऐसे बहुत सारे, व्हेन यू विल गिव द टेस्ट यू विल क्लियरली रियलाइज कि वो टेस्ट कितने ज़्यादा सिमिलर हैं इन द एग्जैक्ट JEE Main पैटर्न. ठीक है, सो डू गिव इट अ ट्राई. आई हैव बीन स्ट्रेसिंग दिस अपॉन फ्रॉम पास्ट सो मेनी लेक्चर्स ऑफ माइन, एंड दिस इज अ वेरी फ्रूटफुल अपॉर्चुनिटी फॉर योर्स. इफ आई वुड हैव बीन ऑफ योर स्टेज एंड मुझे ऐसी अपॉर्चुनिटी मिलती, आई वुड हैव बीन रियली डिलाइटेड. But still you are having it, and you should definitely use it. This is the interface of our app. You can access unlimited amount of practice questions from whichever topic you like, and साथ ही साथ आप tests भी दे सकते हो. टेस्ट में बहुत सारे वेरिएंट है, ट्रेंडिंग टेस्ट भी हैं, टेस्ट सीरीज भी रन कर रही है. टेस्ट सीरीज अभी आपको ऐप पे लाइव हो जाएंगी, स्ट्रिक्टली इन लाइन विद आवर क्रैश कोर्स. अभी आपको जो लाइव है दैट इज द टेस्ट्स, 15 क्वेश्चंस के टेस्ट्स हैं जिन्हें आपको देना चाहिए. फिजिक्स के, केमिस्ट्री के, मैथ्स के, तीनों के यू शुड गिव एंड ट्राई एंड टेस्ट एंड ट्राई एंड नो व्हाट एक्चुअली योर लेवल इज ओवर देयर. ठीक है, सो नाउ लेट्स मूव अहेड एंड टॉक अबाउट द फर्स्ट टॉपिक. फर्स्ट टॉपिक ऑफ आवर डिस्कशन टुडे इज इलेक्ट्रिक चार्ज. सो पहले मैं एक बात बताता हूँ आपको, इलेक्ट्रोस्टैटिक्स क्या है. स्टैटिक इन इटसेल्फ मीन्स एट रेस्ट. ओके, सो इलेक्ट्रोस्टैट्स बहुत इजीली वर्बली भी समझ में आ रहा है. It will be the discussion of charges which are at rest, and that's what electrostats is. So electrostats 1 and 2, जिसमें आप electric field, forces based on Coulomb's law, then potential, then capacitance, उसके बाद potential energy, जितनी भी चीज़ें आप पढ़ोगे, you will be studying them in sync with कि charges are not moving. चार्जेस आर एट रेस्ट, एंड चार्ज कहाँ मूव करने लग जाएंगे जैसे आप करंट इलेक्ट्रिसिटी में जंप करोगे. सो जो थर्ड यूनिट आएगा हमारे क्रैश कोर्स का, वो हो जाएगा करंट इलेक्ट्रिसिटी, जिसमें यू विल बी ओनली स्टडिंग अबाउट चार्जेस विच आर इन मोशन, विच आर मूविंग विद कांस्टेंट वेलोसिटी. एंड उसके बाद जब मैं बात करूंगा मैग्नेटिज्म की, तो वहां पे आ जाएगा जब चार्जेस एक्सेलरेट कर रहे हैं या चार्जेस मूव कर रहे हैं. दोनों ही केसेस में चार्जेस एक्सेलरेट करेंगे तो EM वेव्स क्रिएट होंगी, चार्जेस मूव करेंगे जैसे कि करंट में, तो चार्जेस मूव करेंगे, उससे रिलेटेड क्या प्रॉपर्टी, अब चार्जेस मूव करने से क्या क्रिएशन हो रहा है, वो हो जाएगा मैग्नेटिज्म. तो ये सारी चीजें स्ट्रीमलाइन ऑर्डर में होनी चाहिए. सो यू शुड बी वेरी क्लियर विद द फैक्ट दैट प्रेजेंटली व्हाट वी विल बी डिस्कसिंग इज अबाउट इलेक्ट्रोस्टैट्स, एंड दैट इज ऑल द चार्जेस आर केप्ट इन स्टैटिक कंडीशन, एंड उनके स्टैटिक कंडीशन में रहने की वजह से क्या क्या प्रॉपर्टीज इन्वॉल्व होती हैं उससे. तो सबसे पहले तो बेसिक बात करते हैं एक चार्ज की, कि चार्ज क्या है. चार्ज ऑब्वियसली दो टाइप्स का है, पॉजिटिव एंड नेगेटिव चार्ज. कैन वी क्रिएट अ पॉजिटिव चार्ज? Yes, we can. Can we create a negative charge? Yes, we can. But how we can create it? So the charges created on any body will obviously because of the loss of electrons or the gain of electrons. लॉस ऑफ इलेक्ट्रॉन होगा तो नेगेटिव चार्ज हो जाएगा, गेन ऑफ इलेक्ट्रॉन होगा तो पॉजिटिव चार्ज हो जाएगा, एंड इट इज एज सिंपल एज दैट. एंड दिस इज द रीजन इलेक्ट्रिक चार्जेस ऑन एनी बॉडी आर क्वांटिफाइबल इन नेचर. They are quantified with a numeral multiplied by the charge carried by one electron, because 1, 2, 3 जितने भी इलेक्ट्रॉन्स आप निकालोगे उतना ही चार्ज उस बॉडी पे पॉजिटिव आएगा और जिसको दोगे उतना ही चार्ज उस बॉडी पे नेगेटिव आएगा, ठीक है। ऐसा यूनिट की बात करूं तो ऐसा यूनिट इज कूलम, राइट। एंड इसकी एक सीजीएस यूनिट भी होती है जो कि स्टार्ट कूलम या इलेक्ट्रोस्टैटिक यूनिट भी कहलाती है। एंड रिमेंबर दिस यूनिट जो कि होती है 1/3 × 10⁻⁹ कूलम्स, ठीक है। सो एक सीजीएस यूनिट होती है इलेक्ट्रिक चार्ज की। Okay sir, first class. And if I talk about the properties of electric charge, then obviously they are quantized. As I told you, the total charge on any body will be equal to plus minus Ne, where Ne is what? Ne is the charge of each electron. हर एक electron पे जो charge है that is 1.6 × 10⁻⁹ कूलम, उसके न्यूमरल में ही होगी, उससे मल्टीप्लाई करके ही होगी, ठीक है। दे आर एडिटिव इन नेचर, ऑब्वियसली आप चार्ज डालते जाओगे दे विल एड अप, निकालते जाओगे तो माइनस हो जाएंगे। एडिटिव का मतलब ये नहीं होता सब्ट्रैक्ट नहीं हो सकते, एडिटिव का मतलब होता है उनको जोड़ने के लिए जस्ट हैव टू डू प्लस। अब वो पॉजिटिव चार्ज होगा तो प्लस हो जाएगा, नेगेटिव चार्ज होगा तो ऑब्वियसली माइनस हो जाएगा, ठीक है। चार्जेस आर इनवेरिएंट विद स्पीड। ओके, व्हाट डज दैट मीन बाय दिस स्टेटमेंट इज दैट मास इज नॉट इनवेरिएंट विद स्पीड। विद द चेंजेस इन स्पीड मास चेंजेस। Okay, so with changes in speed mass changes, even time changes. And where we learn about these things, so this is the basic concepts under GTR, that is the general theory of relativity, wherein we speak about how mass and time, mass is relative, ये तो हम atomic physics में ही पढ़ते हैं, then chemistry में भी you must have heard that famous equation m is equal to m naught divided by 1 minus v square by c square. So this shows that with velocity of any object its mass changes, but charge never. So charge is invariant in speed, and you should be very well clear with this. Charge is obviously of two kinds, positive and negative. This is I have very well told. Unlike charges repel each other, unlike charges attract each other. This is also pretty common to all of you. You must have been hearing about these from your elementary classes as well. Then total charge on an isolated system is conserved, and this is one of the conservation laws. So one of the conservation laws is that charge on any system is always constant. Okay, if that system is an isolated one, that means charges are not taking out of it. Okay, so this is one of the conservation laws as well, which says that charges are conserved, conservation of charges for an isolated system. There can be interchanging of charges between them, but since it's an isolated system, that means with the outside or the surroundings no interaction is occurring. That means no change in or no transfer of charges are occurring, and this is what conservation of charge is. Okay, let's move ahead and talk about the very famous Coulomb's law, from where our core electrostat starts. So you all must have heard about gravitational law, right? Universal law of gravitation given by Newton. So what it says is, it says that two masses, they attract each other, and the force of attraction is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. A very landmark statement, and yes, that is. So in sync with that, Coulomb's law is also like that. Two charges. Now the force cannot be attraction, it can be repulsion as well, because charges are obviously of two types, positive, negative, and masses are of two types. Obviously there are antimatter as well, but antimatter are not that distributed over here in a real world, right? We have detected antimatter, that's true, but antimatter are not they are in presence. There is no sun antimatter present over here, right? So they can attract each other, but charges are there. There is one positive and negative. Okay, so the force can be attractive, it can be repulsive even, but the magnitude of the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them, and this is what Coulomb's law is all about. So that he told about the proportionality. Now to remove that proportionality, we need to multiply a constant, and the constant over here is 1/4 pi epsilon naught. So what does this 1/4 pi epsilon naught does is, it actually gives you a hint about the medium. So depending upon the medium, that force will actually change or will be so for space, if I talk about that, epsilon naught is has a fixed value, which I'll be just telling you about. Okay, so epsilon naught is obviously 8.85 × 10⁻12 for free space, but if you change the medium, then this epsilon naught also changes. Okay, this epsilon naught also changes, and depending upon medium to medium, the force also changes. So the change of medium, the element of the change of medium on the Coulomb law, or the force of attraction and repulsion between charges, is obviously into action, and that will be governed by this epsilon naught. But apart from that, mostly if the medium isn't changing, So there isn't much change when we take into account the charges or the forces in air or in vacuum. Okay, so over there the forces are directly proportional to the product of the charges and inversely proportional to r square over r square only, and you just need to keep these two things only in mind. So your entire stress should only be on the product of charges and the square of the distance between them. There can be some cases about dielectrics and all, but we will be discussing them very nicely in capacitance, and there you will get a very good idea how medium can change and how it can affect the value of force, the Coulomb force, or the electric field or electric potential, and so many quantities. Okay, so for the time being, let's focus on this. And what is the value of this constant? So the value of this constant is nearly equal to 9 into 10 raised to the power 9. Okay, and unit is obviously Newton meter square plus Coulomb square. So I suppose you understood this. Now, as obvious as is the case was with gravitational force also. So suppose the force on this was towards here and the force on it was towards this side. So they both were actually making an anti-parallel vector pair, right? So the same result happens over here if F12, that is the force on charge 1 because of charge 2, has a direction towards left. Okay, so F21 will obviously have a direction towards right because they are obviously repelling each other, since the case is of two like charges. If the case would have been of two unlike charges, then the force would have altered and an attractive force would have been into action, and the same result would have been applied over here. So the forces, they are always opposite to each other. And can you write the vector form also? Yes, you can definitely. What you just need to do is just define any r vector. So if suppose this is your r vector, you have defined the r vector, right? So just have to take the direction of it. And how can the direction be taken? Just by taking the unit vector of r. So take the unit vector of r and multiply it with whichever quantity you want to find. So suppose I want to find that. So F21 is 1 upon 4 pi epsilon naught q1 q2 by r square multiplied by r cap. And the direction of F21 is obviously in the direction of r cap. But if I talk about this, the direction of it is opposite to r cap. So I will multiply minus r cap over there. True. And this is how vectorically we can represent the force vectors. So it was not much of a big deal over here, right? But if the charges are surrounded by a medium, then what happens is this k element now gets multiplied, and as I told you, we will be discussing about this dielectric constant or the relative permittivity of the medium. So epsilon naught over here is known as the permittivity of the medium. Okay, so this k, relative permittivity or dielectric constant of the medium, will be discussing and stressing upon in capacitance. But for the time being also, you should have an idea that, say suppose the medium has been changed, what you just need to do, you just need to multiply a k over here whose initial value is obviously equal to epsilon by epsilon naught. And what is epsilon? It is the permittivity of that medium, and epsilon naught is obviously the permittivity of the medium of free space. So epsilon naught is the permittivity of free space, it is the permittivity of that particular medium. Just medium में रखा उसकी permittivity divided by permittivity of free space, and this will give you the value of k, that is dielectric constant or relative permittivity, and you just need to replace it over here. You will get the final value of the Coulomb law of the force, the electrostatic force which is occurring between two charges. Okay, and obviously the k's value has to be between 1 and infinity. So 1 will be the value when I am talking about free space, and infinity is the value when I am talking about conductors. So in conductors, k becomes equivalent to infinity. Okay, and as I told you, don't stress upon it. We will be discussing it in the second part. Okay, so for the time being, you should just keep this in mind. And now let's discuss some very important points about Coulomb law. So Coulomb law also has some restrictions. Okay, the first restriction is this is just the feature of it, that if q1 q2 is greater than 0, that means both of them will obviously be positive or negative, and the force will obviously be repulsive. When it becomes lesser than 0, they are obviously unlike. Now this force is central and conservative. So this is very important. This force is conservative in nature, and I am talking specifically about electrostatic force. So this should be very clear. Electrostatic force, okay, when the charges are at rest, and so electrostatic forces are conservative in nature. That means you move a charge in a round circular path, and what you will get is the work done by you will be 0. Okay, so work done in a closed circular path will always be 0 whenever I talk about electrostatic charges, because these forces are conservative in nature. Okay, and these are conservative just like gravitational force and just like a spring force. Okay, so keep this thing very clear in your mind. And they're obviously all central forces have the relation with r, as F is inversely proportional to r square. Okay, this force is between two charges and it is independent of the presence of other charges. Yeah, so the point obviously is that the force, suppose there are 2 or 3 charges over here, right? It's Q1, it's Q2 and it's Q3. So this Q2 will have a force because of Q3, and that force will not depend upon Q1. Okay, so that will have obviously a force that will be F on 2 because of 3. And this Q2 will also experience a force because of Q1, and that will be like this. This will be F on 2 because of 1. So the net force on Q2 will obviously be the resultant of that, but what this point says is this F23 will not be depending upon Q1. It has nothing to do with it. So F23 will be KQ2 Q3 upon r square, whatever is the distance between them. Okay, and same goes over here. So this is what that point is stressing you for, and it follows the principle of superposition. So just to vectorically have to add all the forces acting on a body, and what you will get instead is the resultant force acting on that body. Okay, so you just need to add vectorically, and this is pretty clear. So if whenever I am talking about forces, so forces are vector quantities, right? So for the addition of vector quantities, you need to follow vector law of addition. You just cannot randomly add them just like masses are added, because those are scalars, and here we are talking about vectors. Okay, and keep this in mind because forces and electric field both are vector quantities, but when I talk about potential and potential energy, they again now will be scalar quantities. Okay, so it should be pretty clear, and let's solve this question to understand the case. So two identical charged spheres are suspended by strings of equal length. Nice. The string makes an angle of 30 degrees with each other. When suspended in liquid of density 0.8 gram per centimeter cube, the angle remains the same. Okay. If the density of the material of sphere is 1.6 gram per centimeter cube, the dielectric constant of the liquid is, okay, not an issue, not an issue. So what is happening over here is, suppose they are kept in air. These are two charges, Q1 and Q2, and identical charge spheres. So we can assume their charges to be Q and Q, right? Very well, sir. So since they are charged bodies, they will obviously repel each other, right? They are identical. So there will be an electrostatic force, Fe. Okay, there will be an electrostatic force, and you are absolutely correct. And they have created an angle. It is given as 30 degree. So let's consider it to be theta. We'll see to it what can be done, but for the time being, let's consider it to be theta, and not theta even. Let's consider it to be equivalent to 2 theta. Okay, no problem. There will obviously be an mg force, and over here also mg. And how, sir, you are very sure that mg force will be acting on both of them? Because they are identical. That they have given very clearly two identical charged spheres. Okay, and over here T will be in action, over here also T will be in action. So can I do one thing? Can I just break the components of T? So if this is 2 theta, this is obviously going to be theta, and this is also obviously going to be theta. So T will have a component over here, this angle will be theta, it will be T cos theta, and over here it will be T sin theta, and same will be the result over here. T will have a component of T cos theta, and over here as T sin theta. So T cos theta will obviously balance mg, and T sin theta will obviously balance Fe. Okay, now when the entire apparatus is set up in a liquid whose density is given to us as 0.8 gram per centimeter cube, so whatever be its density, there will be a buoyant force, right? And if you haven't studied fluid mechanics, then how can you expect you will solve this question? And this is what I was telling you at the start of this lecture only, that all the concepts which you have studied of 11th mechanics, they are going to be used over here. And see the concept of fluid mechanics, that is how Bernoulli's principle, how buoyant force based on Archimedes principle will be exerting a buoyant force over here, and changes will occur according to that. So you need to understand them. This is what I was stressing you upon. Now let's say let's use this color red. Okay, so now let's say this entire apparatus has been kept in water. So now what will be the change now? So the change will be, there obviously will be an Fe force, and what they are instead saying is, in addition to that, there will be a force due to buoyancy as well. Okay, now because of this buoyancy force, what should occur? actually because of this buoyancy force, there should be more separation now between them, right? But what they have said is the strings make an angle 30 degree with each other. When suspended in liquid, the angle remains same. The angle remains same. That means now also 2 theta angle is being created. Okay, that's quite wondering how 2 theta again is being remained. And the reason why 2 theta angle is still remaining is this Fv dash has decreased. So let's use some concepts of rotational also over here. So because of the presence of Fv, there will be a torque generated, right? A torque getting generated and expanding the angle between them. उन दोनों के बीच का angle increase होगा because एक torque generate हो रहा है because of the buoyant force. अभी torque angle increase कर रहा है तो angle decrease कौन करेगा? ये जो Fe है ये reduce हो जाएगा. ये reduce होगा. क्यों reduce होगा? Because I have just told you with the change in medium, the force of Coulomb's law or the electrostatic force also reduces, right? So we need to calculate, and we need to calculate the dielectric constant even. Okay, so यहाँ पे I will write it to be Fe dash and Fe dash, and rest other things remain as it is. This will be mg, this will be mg. Also T will have a component, so this angle again will be theta, so T will have a component over here as T cos theta and over here as T sin theta. Okay, so if you can just look, just focus on any one of the spheres on both the cases. So in this case, T cos theta will be equal to mg, T sin theta will be equal to Fe. Can I divide them? Yes sir, you can, and I'll be writing that only. So in one of the cases, T sin theta was equal to Fe. So T sin theta was equal to Fe and T cos theta was equal to mg. And let's divide them. So what I'll get is T gets cancelled, so tan theta will turn out to be Fe upon mg. Very well. Now what happens in the other case? So in the other case, what happens is T cos theta plus Fb now will be equal to mg. That means T cos theta will be equal to mg minus Fb. Yes sir, very good. So T cos theta will be equal to mg minus Fb. Yes, true. And if I talk about T sin theta, then it will be equal to Fe dash. So T sin theta will be equal to Fe dash. Now again I am going to divide both these terms. So what will happen? T will get cancelled. So tan theta will turn out to be Fe dash divided by mg minus Fb. Okay sir, very well. And the best part about this thing is this tan theta, we don't have to calculate its value because we just are going to equate both of these terms. We are just going to equate both these terms and writing the final answer. So on equating both these terms, what I finally get is that Fe upon mg is equal to Fe dash divided by mg minus Fb will be rho Vg. If you remember the 5th of November, if you remember the buoyant force, then buoyant force is obviously equal to rho times V times G. Okay, very well. Where rho is obviously the density of this fluid, V is the volume of the sphere, and G is acceleration due to gravity. Okay, sir, very good. Now, how Fe will be changing? So if you remember the Coulomb's law, then Fe was just changing by the addition of a k in front of 1 upon 4 pi epsilon naught. So in front of just epsilon naught, we just have to multiply a term with the name k, and that's what we need to find. And rest all other quantities remain same. The distance between them remains same, the individual charges remain same, and 1 upon 4 pi epsilon naught will also remain same. So what I can do is this Fe will be equal to 1 upon 4 pi epsilon naught q1 q2 by r square. This will be equal to 1 upon 4 pi k epsilon naught q1 q2 by r square. And both these terms of 1 upon 4 pi epsilon naught q1 q2 by r square can be cancelled on both sides. So only what will be remaining is 1 upon mg is equal to, over here it will be 1 upon k, and here it will be mg minus, and I am going to make some alterations over here as well. Okay, so can I write the volume of the sphere? Can I write the volume of the sphere to be its mass divided by its density? Can I do that? Yes, you can. Yes, I can. So I'll write its mass divided by its density. Okay, very nice. And now again what is happening is mg will get cancelled. This is the best part. So what I am remaining up with is 1 will be equal to 1 upon k, 1 minus rho by sigma. Now what is the value of rho? So rho has been given to us as density of liquid is 0.8 and sigma has been given to us as the density of sphere to be 1.6. So what I can do is 1 will be equal to 1 upon k, 1 minus rho is 0.8 and sigma is 1.6, and this will surely amount to 1 by 2. So 1 minus 1 by 2 is 1 by 2. 2 will go above, here k will come, so k will finally come out to be equivalent to 2. And I suppose you have just got the answer. And this is the answer and this is the approach how we have to find the answer. And are we correct? Yes, we are definitely correct. So if you understood this application, if you understood this result, how we finally got to the right answer, just hit the like button and also comment over here whether you are loving these sessions or not. If you want any changes in the explanation part, tell us right away. I've been again and again telling you people, you have been watching the series but after some time. It's very good if you can watch it live because you will have so many doubts and I'm over here just to resolve them. So try watching them live, it will definitely be a very beneficial exercise for you and this is the approach to get to this answer. Okay, now let's solve another question, a very good one. So two charges each equal to q are kept at x is equal to minus a and a on the x axis. Okay, a particle of mass m and charge q naught equals to q by 2. So all of the charges are positive, okay, is placed at the origin. If the charge q naught is given a small displacement y, which is very less than a, along y axis, the net force acting on the particle is proportional to, okay, not an issue. So what happens is, this was the setup and I just displaced this particle by a distance y, okay, and obviously these distances are a apart. Okay, this distance is a and even this distance is a, and it is very well given to us that y is very less than a. So don't just go over with the figure being created over here. It has been created just to make you understand what is happening, but in turn in reality this y is very small as compared to this entire distance. Okay, okay sir, perfect. Now what I need to do is, I will be just trying and calculating the forces experienced by q by 2 because of both the charges. So because of q it will experience a force like this, and because of this q it will experience a force this one, and obviously this distance is same, this distance is same, so I can just term it to be r, right. So the force over here will be F and it over here also it will be F, and since if I consider this distance to be theta, so I can very well consider this angle also to be theta. This angle is considered to be theta, this angle can be also considered as theta. So F will have a component over here as F cos theta, and similarly this angle will also be theta, so F will have a component over here as F cos theta, and both these F will have a component in vertical direction. I can term it to be 2 times F sin theta, because F sin theta plus F sin theta I have cumulatively written them as 2F sin theta. So this F cos theta will obviously cancel each other, and the only force remaining on this q by 2 will be 2F sin theta, right. So 2F sin theta is the net force, okay, nice. Now since this y is very small, this r is obviously what? This r will be under root of a square plus y square, right. But this y is very small, it is given to us as to be very small, y is very मतलब ऐसा सीन है कि एक समुद्र में से जो कि a लंबाई का है उसमें से एक बाल्टी पानी जिसकी लंबाई मात्र y है वो निकाल दिया. So what is going to be the difference in the amount of volume in that ocean? It's going to be very nil effect. So this a square plus y square or a square minus y square can be considered to be very near to a only. So this entire result, so r will finally turn out to be nearly equal to a. So I can just apply it over here. So 2 times F will be equal to K Q1 Q2, that is Q into Q by 2 divided by R square will be equal to A square. True, right? This will be the force and the sine theta. Now the main thing is only about sine theta. So what is sine theta? Sine theta will be equal to y by a. So it will be equal to y by a. And obviously the direction in which the displacement has been done, the forces are also in this direction only. So sir, force is coming directly proportional to y. Is this a simple harmonic motion? No, it is not. Why it is not? Because for a simple harmonic motion, the forces should be restoring in nature. That means the net force should have been in downward direction if the displacement was occurring in upward direction, and if the displacement was occurring in downward direction, then the net force should have been in upward direction, and that is the kind of relation which we are hunting for whenever we talk about simple harmonic motion. So in the options also you might have encountered, or there could be some cases wherein they are just asking you a simple harmonic motion is being performed with time period equal to, they'll just relate it with omega square, and you not noticing things very clearly will tick that right option, and there will obviously be an option of none of these as well, which is going to be the right answer over there. So things can be just a bit tricky sometimes. They are in front of you, but as you are used to just mug up the things and not understanding them, you can create a very bad situation for you by just getting the wrong answer. So over here what I can term is that force is, the F net is directly proportional to y and not directly proportional to minus y. Okay, and this is the case because displacement is occurring upward direction, forces are also in upward direction. If forces would have been in opposite direction, I would have easily applied a negative sign over there, but this is not the case. So the question why I have placed it over here is just to make you understand this is not a simple harmonic motion, neither it is an oscillatory motion. This charge, when it is moved, it will keep on moving and moving and never turn back, and this position can instead be termed to be a type of unstable equilibrium, because once it is moved from this position, it never ever will try to again reach the same position, and that cases are obviously under unstable equilibrium. So I suppose you have just understood the result, okay, and the relation, the final relation is equal to y, and this is your right answer. Sachin, you are absolutely correct. Sachin, how are you? Good evening. So electric field, now let's talk about electric field, the next thing. So what I wonder is that we always wonder, we are humans and we are bound to so many things, and when we were kids we always wonder why moon is revolving around us, why sun is also revolving around us, and when we grew older we learned that gravitational forces are actually acting on those heavenly bodies, and because of that these bodies are not leaving us, okay, and so gravitational force we got to know, and but there was still some things happening just around us, as in the case of magnets. So how come a magnet's north pole was attracting the south pole of a magnet or repelling the south pole of another magnet? Okay, so attraction and repulsion, how they were occurring between magnets? Because from childhood what we have been seeing is, if I want to move an object, I will obviously have to push him up, I will have to make a contact with it. Without making a contact, I just want to write some things over here. Can I do that without touching this stylus with the screen? No, I cannot. So to apply any force we need contact, and our brain just cannot digest the fact that non-contact forces do exist. So non-contact forces do exist, they do exist, and the reason of these non-contact forces is that we understand them in the presence of field theory. That means if gravitational force is into action, there obviously is a gravitational field. So a massive body will have its gravitational field all surrounding it, and the gravitational field, in that gravitational field if any mass comes, then that will experience a gravitational force. So the same case happens over here. A charged body will have an electric field surrounding it, and if any charge is present inside or near to that electric field, it will obviously have an effect, or it will have a force because of that electric field. And field theory is obviously the concept to understand non-contact forces, and here we are. So here we are discussing about how electric fields are calculated and what are its properties, and this is going to be a major portion of today's discussion, wherein we will be discussing about the electrostatic field of various charged bodies, and also discussing about a Gauss law which can help us determining those electric fields in a much easier and a much better manner. Okay, so let's start our discussion with, let's say suppose I want to find the electric field due to a point charge. Okay, so I have a point charge which has charge q, and I also have a test charge which has charge q naught. Okay, the case is somewhat like this. So this arrangement, in this arrangement, this q charge will obviously repel this charge, this test charge. This is a test charge. I'm going tests, or I'm doing some tests on it, so the name has been given as test charge, and I want to find the electric field because of this charge q. So what I'm going to do, I'll just calculate the amount of force which is acting on it, divided by the magnitude of this charge only. So F by q naught will give me the value of what? It will give me the value of electric field because of this charge at a distance r. Okay, and I think this is very clear. So in this manner we are very capable enough to determine the electric field due to a point charge, and if we have done that, then that's seriously very good. Now because with the help and with the usage of calculus, we are going to define and find the values of electric field due to so many charged bodies, continuous, non-continuous, and so many. The main portion was that we now know how to find the electric field due to a point charge, a very elemental charge, a very small charge dq as well. So the relation is kq by r square, where k is obviously not dielectric constant. See, in this entire session I will be using k, and k obviously denotes this 1 upon 4 pi epsilon naught, and I will be using this till the time dielectric constant has not again come into action. Okay, so even dielectric constants are represented by epsilon r. Okay, so relative permittivity. Okay, so this was kq by r square. This will be the magnitude, and obviously direction. If I talk about direction, then for a positive charge, the electric field lines will obviously be away from it, and for a negative charge it will be towards it, and I will be discussing about that in the property section. So see, over here also you can find the graphs of it. So if I take a positive charge, then as my x is positive, my electric field lines are continuously decreasing to the inverse power of r square, and as I am coming closer to q, very closer to q, then again r is turning out to be near to 0, and in that case electric field is turning out to be near to a value of infinity. So this is the case when I am moving towards the positive end. If I am moving towards the negative end, then what will happen? The electric field lines now will be towards right. So electric field now will be towards this side, and since this is a negative portion, this is a negative portion, right? So for negative side electric fields are in this direction, and for positive sides electric field are in positive direction, and this is the schematic representation, the graph of E versus X. Now if I talk about a negative charge, so when I am moving, say suppose this is a negative charge, so the direction obviously is towards it only. Okay, so if the positive x is in coming in pictures, if we are moving towards positive x, then electric field lines are towards negative x direction, and hence is the graph like this. As I am moving for the positive direction of x, my curve is actually being created in the fourth quadrant where electric field is negative, and as I am moving towards the left hand side where x becomes negative, then my electric field will obviously towards positive sides, and hence the graph has been created in the second quadrant. Okay. Now let's discuss some very important properties. So they were invented by Faraday to visualize electric field in a region, obviously very good history about it. They are imaginary lines drawn such that the tangent drawn at any point give you the direction of the electric field at that point. So suppose electric fields have been shown something like this, making a curve. So what this means is that electric field lines, they are vector quantities, they are for sure vector quantities. So at every point they will have a direction, and the direction will obviously be in the direction of the tangent drawn at that point. So let's say suppose I want to know the direction of electric field at point A. So what I am going to do, I am going to draw a tangent, and the tangent obviously, so it will be either to downward or upward, and whether it will be downward or upward, this arrow will tell me whether this electric fields are going towards that or towards point A. So obviously electric fields are going like that, so the electric field at point A will be in this fashion, and electric field at point B will be in this fashion, and obviously electric field lines has to be along the tangent only, and this is this point is all about. Okay. Now if I talk about some more properties, then for a positive charge I already told you electric field lines will be emerging out of it, and for a negative charge electric field lines will be eaten up by a negative charge. So positive and negative charge, the electric field lines are drawn like that. Okay. Now if I talk about electric field lines don't pass but leave or end off on charged conductor normally because of equipotential surface of conductor. So this is actually a topic of conductors, and conductors are also a very important topic, but to give you a brief glimpse about it, what happens is there is no electric field inside a conductor. Okay, and the reason to that is the dielectric constant of a conductor is equal to infinity, and this is the reason no electric field ever survives inside it, and the entire conductor becomes an equipotential body. So potential at each and every point will be equal, and this is going to be a topic of discussion in the second part of electrostats. So since each and every point will have the same value of potential, so what do I mean by that is electric field inside is 0 and the electric field lines will be perpendicular to its surface because to all the equipotential surfaces. And what do I mean by equipotential surfaces? That no potential is changing on that surface. So suppose this is a surface and point potential at V1, potential at V2, they all are same, and if they all are same, that means no component of electric field could ever lie on that plane. If because any component of electric field is ever lying, that means we are just contradicting us the same fact that they are equipotential, because the presence of electric field is coming into picture just because of the fact that electric potential is in existence. And don't worry if you haven't got the idea, because electric potential will be discussed much in detail in the second part, but to give you a clear picture, it's just like it starts from a positive charge, it ends on a negative charge. There is no cyclic pattern as in the case of magnetic field lines, wherein outside the magnet it is from north to south and inside it is from south to north. A complete cycle of a magnetic field line is created, but over here it's not like that. There is a start point which will obviously be towards the positive charge, there will be an end point that will obviously be towards the negative charge, and this is how positive and negative charges have electric fields present around it. So as you can see over here, this is a conductor and it has obviously negative charges on its surface. So the electric field lines just made a curve and they made the curvature such that the electric field lines are now perpendicular to the plane of this conductor. Okay. The number of field lines crossing a cross section is proportional to the strength of electric field lines, and that is pretty true. Say suppose if I talk about the same area, let's say suppose this is a charge, right? This is a charge, and I draw a sphere over here. And I just calculate the surface area of this sphere, and I draw the same surface area somewhat like this. So obviously that won't be a bigger circle, right? Because, or a bigger sphere, because obviously in that case the radius will be more, and if the radius is more, the surface area has to be more. So I have to create the surface area equivalent to the surface area of this sphere only, and I create, and the surface area is somewhat like a hemisphere, right? So the amount of electric field lines passing, so what is the amount? So over here the electric field lines are passing, and through this surface all the electric field lines which are generated through this charge will be passing, and over here if I talk about this part, then only half of them are passing. So the intensity, what it tells us that the same area, we considered the same area, but over here the number of field lines are getting reduced, and over here the number of field lines are more. That means the intensity of electric field over here will be obviously more than the intensity of electric field over here. And if they haven't told us, then also we were knowing that E is inversely proportional to R square. That would also have been sufficient for you all to understand, but let's have a statement for it. They have given a statement of properties, so we should understand that fact as well. Now let's look at the distribution of electric field because of the charges as well. So as you can see over here, there are one positive and negative charge, and over here it is two positive charge. With the help of this, I can also draw the diagram of, or the electric field lines of two negative charges even. Okay, so for a positive and negative charge, what happens is electric field lines will be generating out of the positive charge and ending towards the negative charge. And how, sir, is it a method to remember that? Yes, it's very easy. For any point, you can calculate for any point. Let's say I draw it for two negative charges. Okay, so let's say for two negative charges, here is minus q and here is minus q. So what I'm going to do is, I'm going to point out any point in the space. So let's suppose I talk about this point. So the electric field at this point, because of this minus q, will obviously be in this direction, at this point will obviously be in this direction, and this vector is going to be more as compared to this vector. Reason is because this point is very close to this negative charge as compared to this one. So the natural tilt will obviously be towards this vector, and the direction will be like this. Okay, will be like this. And if I talk about this point, the natural inclination should be towards this side. So the diagram of electric field lines for two negative charge is just like that only, just revert the direction of the arrows. Okay, so whatever you have the arrows, you have it like this, just make it like them, and what you will instead get is the electric field arrangement for two negative charges, and what has been represented over here is the electric field arrangement for two positive charges. And for a positive and negative charge, I suppose you have got the idea how it is being done. Now if I move ahead, then now what I have to do is using calculus, I will have to find out the electric field of some very standard charged bodies. So in those standard charged bodies there will be a line charge, there will be disk, there will be ring, there will be solid sphere, there will be a hemispherical shell, there will be a spherical shell as well. So charges will be distributed on it and I will have to calculate the electric fields on them. So the result which you are seeing over here is because of a line charge, because of a finite line charge, not infinite. Infinite also can be done like that, just you have to keep the values of angles, but this expression which you are seeing, the perpendicular component of electric field and the parallel component of electric field, it is because of a finite line charge. That means it is a non-conducting wire. First of all, it is a non-conducting wire because whenever you get charges inside any body, that means those bodies are non-conducting. If they become conducting, the charge cannot reside inside that body. Okay, and good evening Divyapal, how are you? Good evening, good evening. Sachin is asking, sir, laser printer में electrostatics कैसे काम करता है? Okay, so what happens ना Sachin, कि you have an ink, right? You have an ink and that inks need to be placed somewhere. So on a paper those charges are placed and the ink also gains some charges. Okay, there's a toner. I'll be creating a very good short in the coming days about this, a webisode even, to just explain you how this mechanism is working. But for a while you just need to understand ki a normal concept of a laser printer is we need to place that ink on the paper wherever it is required. Okay, and for the impression, for the ink to be placed it over here, to be pressed over here, then it should have a charge and the other portion jahan pe wo ink ko we need to place on the toner, that should have an opposite charge, and based on that the charge gets attracted, and this is how a laser printer is acting or working. And I know I might not be very clear with you because I'll be requiring some images and standard diagrams to explain this to you in a better manner, but wait for a while. You need to subscribe this channel, इस चैनल को सब्सक्राइब करो because बहुत ही जल्द आपको इसके बारे में एक बहुत अच्छा लेक्चर मिलेगा एंड दिस इज ऑब्वियसली इन द प्लानिंग. और इसी चैनल पे, एक्स्ट्रामार्क्स के जेई चैनल पे भी यू विल गेट टू नो हाउ अ लेजर प्रिंटर वर्क्स एंड हाउ इलेक्ट्रोस्टैटिक्स इज यूज्ड इन इट. ओके, सो डोंट वरी. एंड इस टॉपिक पे अगर हम वापस आते हैं, सो यहाँ पे एक लाइन चार्ज दी हुई है जिस बॉडी के अंदर बहुत सारे पॉजिटिव चार्जेस हैं, ठीक है, एंड दे आर ऑब्वियसली इनसाइड द बॉडी. सो इस फाइनाइट लाइन चार्ज की वजह से एक r डिस्टेंस दूर जो इलेक्ट्रिक फील्ड होती है, it can have two components, can have a perpendicular component perpendicular to the line charge, it can have parallel component. Now this parallel component will entirely be depending upon whether the positive charge on the upper side is more or the positive charge on the lower side is more. And if you are very clear with understanding physics, then you can very well understand that if the positive charge on the upper end is more, then the parallel component will be like this, and if the positive charge on the lower end is more, then the parallel component will be like this. And don't worry guys, the relation which you are seeing over here will give you the correct answer. The relation has been meant for that only. Maths को आंसर देना चाहिए. Maths will tell you how to find the right answer. Maths बहुत कुछ कर सकता है, वो आपको बता देगा कि पॉजिटिव आए तो सही डायरेक्शन आपने माना, नेगेटिव आए तो गलत माना है. तो अभी ये जो एक्सप्रेशन है ये कब है? जब हमने E पैरेलल डाउनवर्ड माना है. अगर नेगेटिव आ जाएगा तो हम अपवर्ड मान लेंगे, ठीक है. So in that case, the parallel component is obviously k lambda by r, and k over here is what? It is 1 upon 4 pi epsilon naught, जिसकी वैल्यू 9 into 10 raised to the power 9 होती है. और this is cos beta minus cos alpha. Do remember this thing. So अगर मैं एक इनफाइनाइट वायर की बात कर दूंगा, एक इनफाइनाइट वायर, तो इनफाइनाइट वायर के लिए हाउ विल दिस लाइन जॉइन द इनफाइनाइट पोर्शन? जब वो परपेंडिकुलर हो जाएगी, और ऊपर भी जब वो परपेंडिकुलर हो जाएगी. तो ये दोनों एंगल्स पाई बाय टू cos of pi by 2 minus cos of pi by 2, 0 minus 0, तो एंटायर पैरेलल कंपोनेंट 0 आ जाएगा. ठीक है, क्लियर है? बहुत सही सर. अगर सपोज ऊपर का पोर्शन है ही नहीं, सपोज ऊपर का पोर्शन है नहीं, सो cos of beta minus cos of alpha, तो सेमी इनफाइनाइट वायर के लिए, सेमी इनफाइनाइट वायर के लिए कितनी हो जाएगी? इफ आई टॉक अबाउट सेमी इनफाइनाइट वायर, देन तो लोअर का पोर्शन ये रहा एंड ऊपर का पोर्शन अल्फा विल बी इक्वल टू 0, दिस विल बी इक्वल टू, ओके ठीक है, बिल्कुल सही, परफेक्ट. अगर सपोज सेमी इनफाइनाइट वायर है, सेमी इनफाइनाइट वायर मतलब यहाँ नीचे इन्फिनिटी की तरफ रेस कर रही है, ये पॉजिटिव चार्ज है, एंड आई नीड टू फाइंड द इलेक्ट्रिक फील्ड एट दिस पॉइंट. Let's check. So cos of alpha in that case will be equal to 0. There is no alpha, right? But if I talk about beta, then obviously it will be equal to pi by 2. Because if I draw a line vertical like this, then only I can expect कि वो infinity पे जाके से touch करेगी. So cos of beta is pi by 2, यानी cos pi by 2 minus cos 0. Cos pi by 2 is 0. 0 minus 1, that is minus 1. So the answer will be minus of k lambda by r. And minus of k lambda by r means whatever direction you have assumed of E lambda, it will be opposite to that. So as I told you, नीचे की लेंथ ज़्यादा है तो इलेक्ट्रिक फील्ड ऊपर होगी, ऊपर की ज़्यादा है तो नीचे होगी, एंड मैथ्स ने हमें बहुत इजीली आंसर दे दिया. ठीक है. सो आई सपोज यू हैव जस्ट अंडरस्टूड द रिजल्ट, एंड परपेंडिकुलर कंपोनेंट इस रिजल्ट से निकाला जाता है. मोस्टली परपेंडिकुलर कंपोनेंट यू हैव टू फाइंड. एंड इफ आई टॉक अबाउट एन इनफाइनाइट वायर, जो कि हम गॉस लॉ में भी समझेंगे, सो साइन अल्फा प्लस साइन बीटा, इट विल बी sin pi by 2 plus sin pi by 2, that will give you the result as 2. So 2k lambda by r will be the correct answer. And lambda over here is linear charge density. So you should also remember this. Lambda is linear charge density. And what is lambda? It will be total charge divided by total length. Okay? So let's move ahead and talk about the electric field due to uniform charge ring on its axis, and this is very, very important. This expression which you are viewing in front of you, it is very, very important, and the maximum and the minimum values of electric field at what point they will lie, this is also very, very important. Okay? So अब देखो, ये जो इलेक्ट्रिक फील्ड आप देख रहे हो इस रिंग की वजह से, सेंटर पे जो रिंग होती है ना, सेंटर पोजीशन पे इलेक्ट्रिक फील्ड 0 होती है. ठीक है. बट जैसे जैसे मैं आगे की तरफ बढ़ता जाऊंगा towards this point, electric field magnitude will first increase and then it will decrease, and at infinity it will be equal to 0. Okay. And if I talk about this portion as well, it will first increase, then it will decrease, and at infinity it will be equal to 0. And based on the fact, this is the expression of electric field, and that is the fact only, what is the point where the electric field has maximum value. So the graph is somewhat like this. And the points where you have this maximum value, what you need to do, you just need to differentiate this E with respect to x once, then equate it with 0, try to find out the values of x for which d by dx is turning out to be 0, then again differentiate this expression with respect to x, the second order derivative, and put those values of x which you have just found by equating the first order equal to 0. And just value पे d square E by dx square is greater than 0, वहाँ पे मिनिमम आएगा और लेस देन 0 हो जाएगी, वहाँ मैक्सिमम आएगा. तो आपको लेस देन 0 ही आएगी, और वो जो x की वैल्यू आएगी दैट विल बी इक्वल टू प्लस माइनस r बाय रूट 2. ठीक है. सो एट अ डिस्टेंस इक्वल टू प्लस माइनस r बाय रूट 2, मतलब यहाँ पे द रेडियस इज r, तो ये जो डिस्टेंस है r बाय रूट 2 इन प्लस, एंड पीछे भी यही होगा, सो माइनस r बाय रूट 2, इन दोनों ही डिस्टेंसेस पे जो इलेक्ट्रिक फील्ड होगी वो मैक्सिमम वैल्यू होती है. ठीक है. सो दिस इज द केस, यहाँ पे होती है, और मैक्सिमम वैल्यू कितनी हो जाती है, r by root 2 इसमें डाल दो. इस इक्वेशन में if you put that expression of r by root 2, you will get these values as the maximum values. And I suppose you have just understood how we can find this result. Okay. So now try and solve this question. This question can be solved using calculus, and I want you all to try it. ठीक है. So what we are going to do, we'll be taking a small break, and break के बाद आऊँगा तब इस question को solve करूँगा, and even I'm going to tell you how to find the result when not a semicircular ring, any ring or any part of the ring with an angle of theta given in front of you, तो उस केस में हम कैसे result find करते हैं. By that time I want you all to try for this question and tell me the result in the chat box. Okay, I'll be back in a moment. Okay, so we are back again and चलो मैं आपको इसका सोल्यूशन बताता हूँ, ठीक है. So what we need to do, पहले हम एक काम करते हैं, एक आर्क को कंसिडर करते हैं, एक सर्कुलर आर्क को, एंड जो चार्ज है वो इस आर्क पे डिस्ट्रीब्यूटेड है. सो इस आर्क की वजह से इस पॉइंट पे, पॉइंट O पर क्या इलेक्ट्रिक फील्ड का मैग्नीट्यूड होगा, we'll just try and find out. एंड उसके बाद what we can do is we can just replace that theta by pi and anything else. एंड उसके बाद फिर हम वो पॉइंट पे एक सेमी सर्कुलर रिंग हो या फिर एक क्वार्टर रिंग हो जो कि सिमेट्रिकली प्लेस्ड हो. दिस थिंग इज ऑल्सो वेरी इंपॉर्टेंट. सिमेट्रिकली प्लेस्ड हो या उसके सिमेट्रिक एक्सिस के अबाउट ही हम पता कर सकते हैं, ठीक है. सो लेट्स ट्राई आवर थिंग विथ अ पर्टिकुलर एंगल थीटा. सो व्हाट विल हैपन इज वी आर गोइंग टू यूज सम कैलकुलस ओवर हियर, ठीक है. सो व्हाट आई एम गोइंग टू डू इज आई विल बी कंसीडरिंग, लेट्स से सपोज दिस एंगल इज थीटा, okay, and over here I'll be considering a very small element whose width is obviously d theta, ठीक है. So because of this very small segment of plus charge placed over here, the electric field over here will be somewhat like this, ठीक है, and this angle will be theta. Let's say this electric field is DE, okay. So this DE will have a component over here as DE cos of theta and over here as DE sin of theta. So now what I need to do is I need to use my brain. Say suppose यहाँ पे थीटा पीछे की तरफ जाने पे एक DQ सेगमेंट मिल रहा है जिसकी वजह से यहाँ पे इलेक्ट्रिक फील्ड हो रही है D, जिसका एक कंपोनेंट DE cos थीटा है एंड हॉरिजॉन्टल है D sin थीटा. नाउ गोइंग अ थीटा टूवर्ड इन क्लॉकवाइज डायरेक्शन एज वेल, यहाँ पे भी मुझे एक छोटा सेगमेंट मिलेगा जिसकी वजह से एक इलेक्ट्रिक फील्ड सेम थीटा बना रही होगी एंड उस थीटा का भी उस D का भी दो कंपोनेंट होंगे, one will be D cos theta and another will be D sin theta. So this D sin theta will cancel each other, and if this is a symmetric axis, then for any element you have on the left hand side you will have a symmetric element on the right hand side and the D sin theta components will cancel each other. So all in all what you need to add up is this D cos theta. So the entire electric field will obviously be the integration of D cos of theta, okay. And this is the result. Just we need to do is we just need to replace the value of D and integrate it, and thereby we'll get the final answer. So what will be the value of DE? So I can write DE to be K dq, that is the very small charge remaining over there, divided by whatever is the distance, that is r square into cos of theta. Now this is problematic because we have the variable as theta but a differential element in terms of dq. So we need to replace this dq by some theta and all. So what I can do is I can actually write the expression like, say suppose this q is q charge is remaining in, the entire length is theta, so it is remaining in a length of theta r. True, right? So what can you say about how much value will dq charge remain in? So obviously we know that the length of this segment, this small segment, will be equal to the angle subtended by it at the center into the radius, that is d theta times r will be the length of this small segment. So how much amount will be placed in d theta into r, that will be equal to dq, and what you need to do, you just need to divide both of them. So in turn in doing that you will find the value of dq, and dq will finally turn out to be equivalent to q into d theta by theta, okay. Is it correct? Yes, it is, right. Q by theta into d theta, right. So this will be the value of what? This will be the value of dq. This will be the value of dq. Now perfect. So based on this dq you have found out, you have found the value of this dq. Dq is turning out to be q divided by theta times d theta, and now you need to replace this dq over here in place of this dq and just integrate the result. So what will happen on integration? So integration, the net electric field will turn out to be k times, dq is turning out to be q d theta upon theta, so q into d theta upon theta into cos of theta. Now this entire element, and r square is also obviously there. Now this entire element k q upon r square theta is constant. Theta is what? Theta is the entire angle of it. And if you are getting confused with this theta, I can just replace it by alpha even. Not a big deal, because theta I have considered to be a variable, so I can consider this to be alpha, and over here it will turn out to be alpha into r, and also over here it will turn out to be alpha into r. Okay, alpha into r. ठीक है, परफेक्ट, एकदम परफेक्ट सर. अब इस थीटा की जगह इसको अल्फा रख देते हैं और अब इंटीग्रेट करते हैं. अब इंटीग्रेशन में देखो के क्यू अपॉन आर स्क्वायर अल्फा जो है ये इंटीग्रेशन के बाहर आ जाएगा. इंटीग्रेशन के अंदर कॉस थीटा डी थीटा ही रिमेन करेगा. एंड लिमिट्स कहाँ से कहाँ तक लगानी है, तो लिमिट्स आपको कहाँ से कहाँ तक लगानी है, आई एम जस्ट गोइंग टू टेल यू. सो लिमिट्स के लिए सी, दिस इज द सिमेट्रिक एक्सिस, ये रहा आपका सीन, एंड यहाँ पे टोटल एंगल अल्फा है. सो मैंने यहाँ से एंगल कंसिडर किया, राइट. यहाँ से इधर जा रहा हूँ मैं थीटा एंगल कंसिडर करने के लिए. तो यहाँ से मुझे स्टार्ट कहाँ से करना है, एक एंगल आ जाएगा माइनस अल्फा बाई 2, और कहाँ तक जाना है, मुझे यहाँ तक जाना है, तो वो एंगल आ जाएगा प्लस अल्फा बाई 2. सो मुझे इंटीग्रेशन की लिमिट्स माइनस अल्फा बाई 2 से प्लस अल्फा बाई 2 तक लगानी है. मुझे यहाँ का भी एक डिफरेंशियल एलिमेंट ऐड करना है और एंड यहाँ पे करना है, यहाँ के डिफरेंशियल एलिमेंट में. सो यहाँ पे लिमिट्स आ जाती है माइनस अल्फा बाई 2 से प्लस अल्फा बाई 2 तक, और ये बहुत ही स्टैंडर्ड केस है जब भी आप सिमेट्रिक एक्सिस के अबाउट थीटा कंसिडर करते हो. सो यहाँ पे जो लिमिट्स आएंगी दैट विल बी फ्रॉम माइनस अल्फा बाई 2 टिल प्लस अल्फा बाई 2, एंड जस्ट वेट फॉर अ वाइल. थोड़ी देर में आपके पास एक बहुत ही ग्रैंड एक्सप्रेशन आ जाएगा जिसको आप यूज करके आपको वेदर इट्स स्क्वायर, वेदर इट्स सर्कल और वेदर इट इज अ सेमी सर्कल, अ क्वार्टर सर्कल, जो भी एंगल का दिया हो, आप उसका इलेक्ट्रिक फील्ड एट इट्स सेंटर पॉइंट निकाल सकते हो. ठीक है. सो नाउ इंटीग्रेशन ऑफ कॉस थीटा डी थीटा, इट विल बी इक्वल टू साइन थीटा बाई 2, राइट, के क्यू स्क्वायर अपॉन आर स्क्वायर अल्फा, एंड दिस विल बी इक्वल टू के क्यू स्क्वायर बाई 2. सॉरी, इट विल बी इक्वल टू साइन ऑफ थीटा, एंड लिमिट्स कहाँ से कहाँ तक लगानी है, माइनस अल्फा बाई 2 से लेके अल्फा बाई 2 तक. सो आई कैन वेरी वेल प्लेस द वैल्यूज, राइट. I can very well place the values. Sine of alpha by 2 minus of sine alpha by 2, that will amount to 2 sine alpha by 2. इसका माइनस बाहर आ जाएगा. So finally जो आंसर आएगा E net का, that will be equal to KQ by R square alpha into sine of alpha by 2 minus sine of minus alpha by 2. See, cut this expression and it will turn out to be sine of alpha by 2 minus of sine of minus alpha by 2, right? This expression, I am facing space crunch over here. Now it is perfect. Okay. So ये minus sign बाहर आ जाएगा, this will amount to 2 sin alpha by 2, and this 2 will come over here. So finally what you are getting, the expression is the net result, the net electric field will turn out to be KQ upon R square as it is, and it will be sine of alpha by 2 divided by alpha by 2, and this is the expression which I wanted you all to understand. Okay, so now what is given in front of us? इस केस में अल्फा ये एंगल था, हमें क्या दिया हुआ है, एक हेमिस्फेयर, सॉरी एक सेमी सर्कल दिया हुआ है, एंड सेमी सर्कल में अल्फा की वैल्यू कितनी होती है, सेमी सर्कल में अल्फा की वैल्यू होती है पाई. सो यहाँ पे पाई बाई 2 डिवाइडेड बाई पाई बाई 2, और देख लो जो भी आंसर आ रहा है, 2 पर चला जाएगा के क्यू स्क्वायर, के की जगह 1/4 पाई आंसर रख दोगे तो आ जाएगा. अगर मैं इसकी जगह इन प्लेस ऑफ दिस इफ आई कंसिडर अ रिंग, तो अल्फा की वैल्यू 2 पाई, तो 2 पाई अपॉन 2 इज साइन पाई 0, तो एंटायर आंसर विल बी 0. तो एक रिंग के सेंटर पे ऑब्वियसली इलेक्ट्रिक फील्ड 0 होती है. अब आपको रिंग दी हो, एक पूरा सेमी सर्कुलर रिंग दी हो, या एक क्वार्टर सर्कुलर रिंग दी हो, या 3/4 ऑफ अ रिंग दी हो, अगर उसके सिमेट्रिक एक्सिस के अबाउट, उसके सेंटर पॉइंट पे आपको इलेक्ट्रिक फील्ड पता करनी है, यू कैन वेरी वेल यूज दिस फॉर्मूला एंड गेट टू द फाइनल रिजल्ट. सो दिस इज द पॉइंट विच आई वांटेड यू ऑल टू अंडरस्टैंड. बाकी सब यू कैन जस्ट एवेड ऑफ, यू जस्ट नीड टू कीप this thing in mind, how KQ by R square, how electric field can be calculated at the central point, and the final answer obviously will be this only. What you just need to do, you just need to replace this alpha by pi, and you'll get this final answer only. ठीक है. And why minus j cap? Minus j cap means it is in downward direction. Obviously अगर positive charge distributed है तो जो इलेक्ट्रिक फील्ड होगी डाउनवर्ड डायरेक्शन में होगी, नेगेटिव चार्ज होगा तो अपवर्ड डायरेक्शन में होगी, एंड दिस इज अ फैक्ट, दिस इज ऑब्वियसली अ फैक्ट। हमने पॉजिटिव चार्जेस ही कंसिडर किए, अगर इसकी जगह नेगेटिव चार्जेस आ जाते हैं तो फिर इलेक्ट्रिक फील्ड का डायरेक्शन अपवर्ड डायरेक्शन में हो जाएगा, ठीक है। सो नॉट अ बिग डील, उस समय भी यू कैन जस्ट calculate the answer, magnitude will remain same, just direction will change. Now let's move ahead and talk about electric dipole and dipole moments. So now what is an electric dipole? So whenever you have a configuration of two charges, positive and negative, then there becomes a dipole, just like a magnet. So you have a north and south pole. Over here we have a positive charge and a negative charge of equal magnitude. So if there is a plus q minus q, then there becomes a dipole, and obviously the dipole moment of that dipole will be represented by the letter p with a vector. It will be a vectorical, it will be a vector sign and a vector quantity even. The direction of p, always remember, the direction of p will always be from negative to positive. The direction of a dipole moment is always from negative charge to positive charge. नेगेटिव चार्ज से पॉजिटिव चार्ज की तरफ जाने वाला डायरेक्शन ही डायपोल मोमेंट का डायरेक्शन होगा। एंड मैग्नीट्यूड कैसे पता चलेंगे? तो मैग्नीट्यूड विल बी इक्वल टू क्यू, जो भी चार्ज का आपने डायपोल बनाया, जो भी कॉन्फ़िगरेशन है जिस चार्ज की, क्यू मल्टीप्लाइड बाय द टोटल डिस्टेंस। सो यहाँ पे टोटल डिस्टेंस हैज बीन कंसिडर्ड एज 2a, सो 2q into a, मतलब q into 2a, एंड अगर डिस्टेंस l होता तो q into l। एंड व्हाट इज द रीजन? ये बहुत स्टूडेंट्स, मेनी स्टूडेंट्स हैव आस्क्ड सर हम 2a क्यों लेते हैं? 2a इसलिए लेते हैं बिकॉज इसके बाद जब हम एक्सियल और आपकी इक्वेटोरियल पॉइंट पे इलेक्ट्रिक फील्ड्स कैलकुलेट करेंगे ना, सो उस समय this considerance of the distance between both the charges as 2a will help us brilliantly, क्योंकि in that case हम इसके मिड पॉइंट से डिस्टेंसेस मेजर करेंगे तो r माइनस a का एक एलिमेंट आ जाएगा। You can even take it to be d, you can even take it to be l. You just consider distance multiplied by the charge जिसका भी डायपोल क्रिएट हो रहा है। डायपोल मीन्स दो पोल्स और दोनों पोल्स का मैग्नीट्यूड सेम ही होना चाहिए, अनइक्वल चार्जेस का डायपोल नहीं बन सकता, ठीक है। So this is the concept about dipole moment, and for an example H2O, so H2O has 105 degree angle, ठीक है। केमिस्ट्री सर से you can very well ask ये एंगल कैसे क्रिएट हो रहा है, एंड दिस एंगल, इसमें भी एक डायपोल क्रिएट होगा। कैसे होगा? यहाँ O पे दो नेगेटिव चार्जेस हैं, एक नेगेटिव यहाँ आ जाएगा, एक नेगेटिव यहाँ, इस नेगेटिव और इस पॉजिटिव से एक डायपोल ये क्रिएट हो गया, इस नेगेटिव से इस डायपोल पे एक ये क्रिएट हो गया। तो ओवरऑल इन दोनों का वेक्टर सम लूंगा तो इनके ये कंपोनेंट्स कैंसिल अप हो जाएंगे, एक ये रह जाएगा, एंड देयर इज अ डायपोल associated with H2O molecules. Okay, so depending upon electric field, the H2O molecules can also move because they have a dipole moment. They can also rotate, they can have a torque on them, and I'll be telling you very clearly how it is possible. Okay, so H2O has a dipole in it, and you can very well calculate the angle. 105 है तो this will be equal to 52.5 52.5, और उसका cos component लेके twice कर दोगे तो you will get the answer, ठीक है। Let's move ahead and solve this question. So charge distribution at three vertices of an equilateral triangle of side A is shown in the figure. The net electric dipole of the system is, ठीक है, no problem. So यहाँ पे हमें -4q दिया हुआ है, यहाँ पे 2q और 2q दिया है। अब what I told you, dipole हमेशा दो equal charges के पेयर से ही बन सकते हैं, ठीक है। So यहाँ पे 2q का बन सकता है, no, equal and opposite नहीं है। यहाँ 2q है, यहाँ -4q है। So what we'll do, we'll just break this -4q into two parts, as in the case we did it with oxygen. It had two minus charge. हमने उसको दो पार्ट्स में ब्रेक कर लिया था, एक माइनस और माइनस, और उसको H प्लस से हमने कंबाइन करके एक डायपोल क्रिएट कर दिया था। एंड द सेम थिंग वी आर गोइंग टू डू ओवर हियर एज वेल। एक डायपोल इस -4q के, इसमें यहाँ पे दो चार्जेस देखो आप, एक -q और एक -2q और। इस -2q और इस +2q का एक डायपोल बनेगा, इसका एक डायपोल बनेगा, और उन दोनों का रिजल्ट ही हमारा फाइनल आंसर होगा। तो एक डायपोल आपका ये बन गया, एक डायपोल आपका ये बन गया, एंड स्ट्रेंजली दोनों का मैग्नीट्यूड सेम होगा। क्यों? क्योंकि मैग्नीट्यूड चार्जेस का सेम है और ये डिस्टेंस भी सेम है, बिकॉज इट्स एन इक्विलेटरल ट्रायंगल, राइट। सो यहाँ पे P है, यहाँ पे भी P होगा। P का एक कंपोनेंट दोनों का ये 30 डिग्री हो जाएगा, ये भी 30 डिग्री हो जाएगा, तो P cos 30, तो फाइनली द नेट रिजल्ट विल बी 2P cos of 30. So P net will be equal to 2P cos of 30. And what is the value of P? So the value of P will obviously be equal to Q into the distance. ठीक है? So 2 times, what is the Q? Q is 2Q and distance is A, and cos 30 value is √3/2. Everyone knows that. So how much this answer is coming out to be? It is coming out to be 2√3Q into A, and this is your answer. And direction obviously will be towards -y. So the answer is -j cap के along. ठीक है? and I suppose it was very easy and you understood the result. It was very easy. कैसे कर सकते हैं, ठीक है? So based on that, we need to find the net dipole moment of different substances. Now let's calculate the electric field due to various dipoles. So देखो, there are two standard cases and standard positions for the first case. एक standard position होती है axial position, एक होती है equatorial position. Axial position is जिस axis के along हमारा dipole ही रखा हुआ है. So हमारा dipole रखा है ये, और इसी के axis के along हमें एक r distance दूर point पता करना है, and obviously that r should be very very less than a, and in that case we can very well say कि axial position पे जो electric field होगी that will be equal to kp by r cube. K is where 1/4 pi epsilon naught, sorry 2 kp by r cube. And equatorial पे क्या होती है? Equatorial पे will be, the magnitude will be p kp upon r cube, ठीक है? So magnitude at axial position is twice the magnitude at equatorial position. And direction क्या होगा? So direction at equatorial position is opposite to the direction of the dipole moment vector. So यहाँ पे एक negative sign भी आता है if you are considering it in a vector notation. And at axial position the direction is along the dipole. So यहाँ पे positive sign आएगा if you are considering the direction as well. ठीक है? So magnitude you understood and direction also you understood, and this distances are, this distances are. And based on that, now using this only, we can also calculate the value of electric field at any random point in space, Now let's say there is a dipole and we need to calculate the electric field at this point. So what I am going to do now is, I am going to take the components of this P, one along the line perpendicular to the line joining the point where I need to find the dipole moment with the dipole. So एक component ले लूँगा मैं P का जो कि perpendicular है इस line के, इस distance के, जो कि उस point पे जहाँ निकालना है मेरे dipole से connect कर रहा है, और एक component ले लूँगा मैं along the line जो कि join कर रही है उस point को dipole से, ठीक है? So अगर ये angle theta लिया है तो ये वाला component मेरा आ जाएगा P cos theta, ये वाला component आ जाएगा P sin theta. True, very true. And now what the thing is, अब इस P cos theta element के लिए ये वाला जो point है वो axial point बन जाएगा. So इस axial point की वजह से जो इलेक्ट्रिक फील्ड रहेगी वो ये रही 2p cos थीटा अपॉन r की, जो कि इसके अलॉन्ग ही होती है. और ये जो कंपोनेंट आप देख रहे हो जो परपेंडिकुलर इस लाइन की जो p sin थीटा है, उसके लिए वाला पॉइंट इक्वेटोरियल पॉइंट बन जाएगा. तो इसके लिए जैसे यहाँ पे इलेक्ट्रिक फील्ड ऑपोजिट टू द डायरेक्शन ऑफ डाइपोल रहेगी, जो कि हो जाएगी kp अपॉन r क्यूब, और जो कि यहाँ पे p sin थीटा है. So now the net result over here will be the resultant of both these electric fields, जो कि हम very well निकाल सकते हैं अंडर रूट ऑफ a स्क्वायर प्लस b स्क्वायर करके, क्योंकि दोनों परपेंडिकुलर है एंड दोनों निकाल लिए. सो द नेट रिजल्ट विल बी ओवर हेयर, इन दोनों का अंडर रूट करना है. सो द नेट रिजल्ट विल बी दिस 1/4 पाई, दैट इज kp by r क्यूब 1 + 3 cos स्क्वायर थीटा. ठीक है? वन मोर थिंग, आई कैन ऑल्सो कैलकुलेट दिस एंगल. And why I can calculate this angle is, I will be just telling you, this angle will be obviously equal to perpendicular upon base. So perpendicular is this, base is this. This by this will give you the value of tan alpha. So tan alpha will turn out to be half tan theta by 2. Tan alpha will turn out to be tan theta by 2. And why I need to calculate the value of alpha is because now what I can say is, I can very well say that the electric field at this point will obviously be equal to, alpha. तो ये लाइन है तो ये एंगल तो अल्फा हो गया, सॉरी ये एंगल तो थीटा हो गया. सो द इलेक्ट्रिक फील्ड नाउ इज मेकिंग एन एंगल ऑफ थीटा प्लस अल्फा विथ द एक्स एक्सिस, एंड दिस इज द रीजन आई नीड टू फाइंड दिस अल्फा वैल्यू. सो द नेट इलेक्ट्रिक फील्ड मेक्स एन एंगल ऑफ थीटा प्लस अल्फा विथ द डाइपोल मोमेंट, एंड दिस इज द रीजन आई नीड टू कैलकुलेट दैट वैल्यू ऑफ अल्फा. एंड व्हेन E becomes perpendicular to B, थीटा प्लस अल्फा विल बी इक्वल टू 90 डिग्री. ऑब्वियसली इलेक्ट्रिक फील्ड जब परपेंडिकुलर ही हो जाएगी तो इलेक्ट्रिक फील्ड कैसी बन रही है, लाइक दिस. सो थीटा प्लस अल्फा कितना हो जाएगा, 90 डिग्री हो जाएगा, एंड थीटा विल नाउ बी इक्वल टू tan inverse 2. सो दीज आर जस्ट कैलकुलेशंस बेस्ड ऑन व्हाट द मेन क्रक्स इज दिस एंड दिस रिजल्ट एंड हाउ वी अराइव टू दिस रिजल्ट. ओके, सो दिस वाज अबाउट द कैलकुलेशन ऑफ इलेक्ट्रिक फील्ड अराउंड अ डाइपोल. अबाउट द पोटेंशियल you will be studying in the second part how potential can be calculated by the help of a dipole to its nearby points. There is one more very important thing जिसके ऊपर SHM से related काफ़ी questions आते हैं, and this thing is about torque. कि एक torque होता है on a dipole placed in electric field, and the magnitude, the value of that torque is tau is equal to P cross C, And if I talk about the magnitude, then it is PE sin theta, obviously. And direction you very well know, I have taught you using cross product. If you haven't understood rotational motion का chapter, you watch that crash course जिसमें left hand को rule करके cross से पहले वाली चीज middle finger, cross के बाद वाली चीज forefinger, resultant thumb से we can very well find the value and the direction of torque vector जो भी resultant रहता है cross product में. Okay, and the magnitude will obviously be equal to PE sin of theta, where theta is the angle between P and E. And based on that, three kinds of equilibrium also exist, and I'll tell you very nicely. So first let's take the case when P is perpendicular to E. P is perpendicular to E, so maximum value of torque आ जाएगी, that will be equal to P is perpendicular to E, then net torque is not equal to 0, net torque will be equal to P into E, that is the maximum amount of torque which can be applied. एंड इस केस में होता क्या है, देखो सारे ही केसेस में जहां पे भी आप बात करोगे इलेक्ट्रिक फील्ड में आपने टॉर्क को रख दिया है, तो दोनों ही, जैसे सपोज ये प्लस क्यू चार्ज है वाला एंड और यहाँ पे माइनस क्यू है, तो प्लस क्यू पे हमेशा इलेक्ट्रिक फील्ड के डायरेक्शन में लगता है और माइनस क्यू पे हमेशा जो फोर्स लगता है वो इलेक्ट्रिक फील्ड के ऑपोजिट डायरेक्शन में लगता है. दिस इज वेरी क्लियर. जो भी फोर्स रहता है बिकॉज ऑफ इलेक्ट्रिक फील्ड, प्लस क्यू पे हमेशा अलोंग द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड रहेगा और नेगेटिव चार्ज पे हमेशा ऑपोजिट टू द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड रहेगा. ठीक है, तो ट्रांसलेशनल इक्विलिब्रियम तो हमेशा रहेगा, फोर्स एक इधर और दोनों बराबर. So translational equilibrium do exist, but rotational equilibrium exists depending upon the configuration which has been created. So in this case, when P is perpendicular to E, obviously translational equilibrium to it is in every case, but rotational equilibrium is not there, and even the rotational torque is its maximum value. But there do occur cases when P becomes parallel to E and P becomes anti-parallel to E. And in this case what happens is, suppose electric field is in this fashion, so there is a dipole plus over negative over, so this is the case like this, and in this case what I can very well say is that the force obviously over here will be QE, over here it will be QE, and translational equilibrium तो है, but यहाँ पे rotational equilibrium भी है, because net torque is how much? It is PE sin of theta, right? It is the magnitude, and sin theta is what? Theta over here is 0, so sin 0 0, that means net torque is 0. So this is a condition of equilibrium, and even when it is anti-parallel, then also sin pi it will be 0, then also it's a case of equilibrium. But there's a change. At this point the equilibrium is of stable equilibrium, that is if you just change it a bit, then also it will again regain its shape. But in this case, when the electric fields are like this and the dipole has been placed like this, if you just change it, alter it a bit, it will again regain the shape of a stable equilibrium and never ever regain the same shape or the same configuration from which it has been disturbed. So this case is of unstable equilibrium. Okay, and you should very well keep in mind what is unstable and stable. It can also be understood on the basis of potential energy. So potential energy is also defined in terms of electric dipole placed in electric field, and this is going to be discussed in the second part, but still I am telling you potential energy is minus of P dot E, and this gives you the value of minus PE cos of theta, right? So if I am talking about this position when theta is equal to 0, obviously potential energy you can see minus PE cos 0, that is minus PE, that is the minimum. So over here the potential energy is minimum, and if I talk about this position when theta is equal to pi, so cos pi is minus 1, so minus minus becomes plus, so over here the potential energy becomes maximum. And this is also a way to understand how stable and unstable equilibriums are created. Over here the equilibrium is there but potential energy maximum है, and यहाँ पे भी equilibrium but potential energy minimum है. So all the bodies, they always try and reach that position where they attain the minimum possible value of energy, and as obvious the minimum possible is there, and this is the case of stable equilibrium, and this is the case of unstable equilibrium where the energy quotient is maximum. Okay, so I suppose you have just understood the result. And angular SHM dipole में कैसे हो सकता है, as obvious stable equilibrium से as I told थोड़ा सा move कराया, थोड़ा सा deflect कराया by an angle theta, suppose by an angle theta. If we have just moved it a bit, so net torque कितना होता है, net torque is equal to PE sin theta होता है. And obviously if from the stable equilibrium, I am talking only about stable equilibrium, so angular SHM is obviously when for a small angular displacement theta about stable equilibrium. So जैसे ही थोड़ा सा move कराया, it will have a potential to regain the same position. So theta आपने clockwise लगाया तो anti clockwise torque आएगा, तो हमेशा एक negative sign रहेगा. And if theta is very small, sin theta can be considered to be nearly equal to theta. tau net can be considered to be I alpha, so alpha will turn out to be minus PE upon I into theta. So क्या वो grand equation आ रही है simple harmonic motion वाली? Yes, alpha is equal to minus omega square theta से compare कर सकते हैं. Angular acceleration is directly proportional to theta with a negative sign. That means omega will be equal to PE upon I. That means time period will be equal to 2 pi under root of I upon PE, where I is moment of inertia, P is the dipole moment, and E is obviously the value of electric field. ठीक है? So in this manner we can very well calculate the time period of angular SHM occurring in a dipole. ठीक है? Now let's solve this question to understand what we have just learned. So an electric dipole has a fixed dipole moment P which makes angle theta with respect to x axis. True. When subjected to an electric field E1 is equal to EI cap, it experiences a torque tau 1 equals to tau k cap. Okay. When subjected to another electric field E2 equals to root 3 E1 j cap, it experiences a torque which is equivalent to the first one, the angle theta is. Okay, ठीक है. So there's a dipole which is making an angle theta with x axis. That's what they're saying. P makes an angle theta with respect to x axis. When subjected to an electric field E1 equals to EI cap. So एक electric field ये रही E1. इसकी वजह से एक टॉर्क लगता है ताउ 1 और इसकी वैल्यू कितनी हो जाएगी? मैग्नीट्यूड बताना है, बिकॉज व्हाट दे आर सेइंग इज दोनों वेक्टर सेम है, यानी मैग्नीट्यूड भी सेम ही होगा. सो हम मैग्नीट्यूड ही निकाल लेते हैं सबसे पहले तो. सो मैग्नीट्यूड कितना हो जाएगा? PE1, P क्रॉस E1 होता है ना, तो PE1 साइन ऑफ थीटा. ओके, ट्रू. नाउ दे आर सेइंग इज व्हेन सब्जेक्टेड टू अनदर इलेक्ट्रिक फील्ड ऑफ E2 रूट 3 I कैप J कैप, रूट 3 E1 J कैप, मतलब एक और इलेक्ट्रिक फील्ड लगाई जो J कैप के अलोंग है, एंड इसकी वजह से टॉर्क कितना हो जाएगा? tau 2. This will be equal to P E2 into sine of this angle that is pi by 2 minus theta. So pi by 2 minus theta कितना होता है? Sine of pi by 2 minus theta is cos theta. So this will turn out to be cos theta. And what they are saying, दोनों बराबर है, दोनों टॉर्क बराबर है, यानी दोनों का मैग्नीट्यूड भी बराबर है. That means PE1 sine of theta will be equal to PE2 cos of theta. So that means PP cancel, tan of theta will turn out to be how much? E2 is 2 E1, and E2 is obviously given to us as root 3 E1. That means E2 upon E1 turns out to be root 3. That means theta turns out to be 60 degrees. Simple, बहुत simple answer था. I suppose you have got the answer. और बहुत easily answer इसका निकल गया. So what is the right answer? The answer is 60 degrees. Okay, so this is the explanation for this question asked in one of the JEE main papers, and I suppose you got the result. बहुत easily इसको समझना था. Expression बहुत ज़्यादा था, बहुत सारे words थे. You just need to segment some few key elements and you could have arrived with the right answer. Okay. Now let's talk about electric flux, because electric flux समझेंगे तभी तो we'll be getting to know what Gaussian law and Gauss law is all about, and how using Gauss law we can very well calculate the values of electric field as well. So electric flux क्या होता है? देखो, electric flux is a quantity defined as E times dA. ठीक है? Here the exact expression is this: phi represent electric flux, that is equal to integration of E dot dA. Now suppose if electric field is constant both in magnitude as well as direction, then this E vector will come outside and integration D vector will be equal to A vector, and you can finally say that phi is equal to E dot A. So on doing the dot product, E cos theta. True. So what do I mean by that is, if the angles between them is equal to pi by 2. Now how to calculate area vector? So area vector, as you can see, electric field we know, as this is a plane, my hand is a plane. So the area vector of this plane will obviously be in the upward direction. So this is the case about two-dimensional bodies, as in the case of square, rectangle or triangle. So these are planar bodies, right? So planar bodies के लिए you have full freedom. आप area vector ऊपर भी ले सकते हो, area vector नीचे भी ले सकते हो. Only the consideration is कि वो perpendicular होना चाहिए surface के, whatever is your surface. Now when I talk about three-dimensional bodies, closed bodies, then in that case area vector is always considered in outward direction. So if I take the case of a sphere, then that means area vector will obviously be in outward direction. If I talk about a cube, then this will have an area vector like this will have an outward direction, the structure over here will have an outward direction, this word direction. So every surface will have an area vector towards outward direction only, not towards inward. And this is a convention just known to calculate area vector, जिससे कि हम flux calculate कर पाएं और उससे हमारा easiness रहे question में, ठीक है. So this is how electric flux is calculated. Now let's say suppose इस केस की बात करते हैं जहाँ E is parallel to A vector. So if I talk about the reality, then E vector is perpendicular to the surface, but since area vector is perpendicular to the surface, that means E and A are parallel. So in this case, phi will be equal to E into A into cos of 0, that means E. But if E vector becomes perpendicular to A vector, then in that case phi will be equal to 0. So flux becomes 0. Flux also becomes 0 when I talk about, let's say suppose this is an open cone. This is an open cone. There can be an example of a closed cone as well, there can be an open cone as well. So open cone is not a closed body. If there is a closed body, if I talk about a closed body, so always remember this statement, for closed body which is not this, this is an open cone, right, the cone which you eat, just my ice cream, we use ice cream wala cone, which is open from this side, okay? This is open, and for a closed body flux is always equal to 0, because the number of field lines if entering is equal to the number of field lines exiting out, then flux will always remain it to be 0. Now in this case the number of field lines, suppose 2 field lines are entering, right, so many field lines are entering and they are entering, but there is no surface beneath, so that there can be an exit, proper exit दे ही नहीं रहे हो. So proper exit दे नहीं रहे हो तो यहाँ पे flux होगा, and flux will obviously be equal to electric field into the perpendicular area, the area vector which is parallel to it. Obviously this will have an area like this, like this, like this, but we need to focus only on the area which is parallel to electric field lines, ठीक है. So what is the area parallel? We'll consider this circular pattern. So out of all these areas, the circular pattern will be the main impression, and obviously the area vector, as I told you, बाहर वाला surface हमेशा outward रहेगा, तो area vector का direction towards this side left होगा, electric field इधर towards left, and this is the reason जो lateral surface की वजह से होगा वो pi r square, and they have given the value of base as well. So if suppose this is not a closed one, this is not a open one, ये open नहीं है, they have taken the case of open one as well, I got confused, ये open नहीं है, closed ही है, ठीक है. बट अगर ये ओपन होता तो हम बस लेटरल सरफेस मतलब बाहर वाले सरफेस की वजह से काउंट करते, दिस सरफेस, ओके, दिस सरफेस जिसमें जो आउटर लेयर्स है, अभी ओपन कोन है, तो ये होता E माइनस ऑफ E इंटू पाई आर स्क्वायर. बट अगर क्लोज्ड होता तो इस वाले सरफेस का जो एरिया वेक्टर होता वो कहाँ होता, दैट वुड हैव बीन टुवर्ड्स राइट, वो ये बाहर की तरफ होता. इस पूरे कर्व सरफेस का एरिया वेक्टर लेफ्ट की तरफ होता एंड इसका बाहर की तरफ होता, तो इसकी वजह से जो फ्लक्स होता वो प्लस में होता E इंटू पाई आर स्क्वायर. एंड इसीलिए जब क्लोज्ड बॉडी होती तो दोनों को ऐड करना पड़ता, तो प्लस और माइनस 0 हो जाते. एंड दैट्स व्हाट आई एम सेइंग, फॉर क्लोज्ड बॉडी phi is always equal to 0. Still not convinced? Let's take this case. Can you just view this कि all the electric field lines entering is equal to exiting? Yes, truly. So what I can say is that the net flux will be equal to 0, and yes it is. Phi entering will be equal to this much, phi leaving will be equal to this much. And if suppose it is just a sphere like this, okay, it is just a sphere like this, so the half of this portion, it is open from this side and it is open from this side, so then electric field lines entering will be equal to E into pi r square by 2. This is a circular, right, and half of this E into pi r square, this side इसकी वजह से होता तो ये बैकवर्ड एरिया होता और ये हो जाता एंटर करने वाला, एग्जिट करने वाला नहीं होता अगर ये ओपन होता तो, बट ये क्लोज्ड है तो इसलिए 0 रहेगा, ठीक है. आई सपोज आई एम वेरी क्लियर विथ यू पीपल कि कैसे फ्लक्स कैलकुलेट करते हैं. सो ये एक बहुत स्टैंडर्ड केस है जिसको आप लोगों को समझ में आना चाहिए. यू शुड वेरी वेल रिमेंबर दिस रिलेशन यू, बिकॉज यू कैन नॉट एट ऑल डिराइव इट, ठीक है. सो फ्लक्स ड्यू टू अ चार्ज पार्टिकल एंड देयर इज अ सर्कुलर डिस्क, सो इसकी वजह से जो इलेक्ट्रिक फील्ड लाइंस रहेंगी लाइक दिस, सो इन इलेक्ट्रिक फील्ड लाइंस की वजह से स्मॉल डीए वेक्टर्स, ठीक है, every DA vector, and there are so many small DA vectors सबके साथ integrate करके when you will do the result, the final flux which will turn out to be will be q by epsilon naught 1 minus r upon under root of r square minus capital R square. And suppose this disk becomes very close to this capital Q, then what will be the value of flux? It will obviously be equal to q upon 2 pi epsilon naught, because in that case r will turn out to be 0. If r is turning out to be 0, then this expression becomes 0. So q by 2 epsilon naught. So if r is very near, if r becomes nearly equal to 0, then flux becomes q by 2 epsilon naught. And this is the case when we'll be using this case, don't worry. So when charge is placed very near to any body, for that body the surface becomes just like infinitely large. If the distance is very small, the surface becomes infinitely large, and in that case the flux remains only q by 2 epsilon naught. So do remember this expression, this is very important expression. Now so all this taiyari and all this study was only for understanding what Gauss law is. So what is Gauss law? So Gauss law actually was very helpful in finding the electric fields of symmetric distribution of charges. Okay, so never ever think that Gauss law is applicable everywhere for sure, but Gauss law is only beneficial for us when there is a symmetric distribution of charge. Okay, and for an unsymmetric distribution of charge, you obviously have to rely on calculus. So using a Gauss law, you cannot find the electric field due to a finite line charge, as we did with the help of calculus, and of infinite wire or infinite line charge we can very well do that. Okay, so what does Gauss law says is, it just says that draw Gaussian surface, draw an imaginary Gaussian surface and do the E dot dA on all the portions of dA elements on it. So dA elements E dot dA, integrate it all, and that will obviously be equal to the Q enclosed, that is the enclosed charge within that Gaussian surface, divided by epsilon naught. Okay, so E dot dA will obviously be equal to the enclosed charge divided by epsilon naught, and this is what Gauss law is. So without applying Gauss law, it never gives us a clear idea. But before going into Gauss law, we still need to understand some more concepts of flux. Okay, so Gauss law must have been understood. After that, we first need to understand the flux as well, because there still remains some elements of flux. So and this is actually the value of flux also. Okay, so this E dot dA, obviously it is the expression of flux, and that is also equal to Q enclosed upon epsilon naught. So now with the help of Gauss law, we can also find the value of electric field, but we also have a new term to find out the flux, electric flux due to any system of charges. So let's take the case of this. There's a charge and there's a cube. Inside the cube a charge has been placed. So can we find the value of flux because of this charge of इस क्यूब में इस चार्ज की वजह से जितना भी फ्लक्स होगा रिलेटेड विद दिस क्यूब, कैन वी फाइंड दैट? यस, एंड द आंसर इज क्यू एनक्लोज्ड अपॉन एप्सिलॉन नॉट, एंड यस इट इज, हियर इट इज. सो अगर ईच फेस से मुझे निकालना हो तो डिवाइड बाय 6 कर दो, बिकॉज वो एकदम उसके सेंटर पॉइंट पे रखा हुआ है. इन इट्स सेंटर पॉइंट द चार्ज हैज बीन प्लेस्ड, सो इट विल बी क्यू बाय 6 टाइम्स एप्सिलॉन नॉट. ट्रू. If I place it at one of the corners, then what happens is, so you can obviously use this result, or you can also find like this is, इसके ऊपर एक और क्यूब रख दो, ठीक है, इसके साइड में एक और क्यूब रख दो, इसके साइड में एक और क्यूब रख दो, एंड इसके सामने भी ऐसे 4 का पेयर रख दो. ये हमने बैक साइड में रखे, ठीक है, बैक साइड में रखे 1 2 3 4, एंड इसके सामने में भी 4 क्यूब्स रख दो. So now this charge will be completely enclosed, okay, and through that entire system of 8 cubes, the total flux will be equal to q by epsilon naught. So if I talk about one of the cubes, then it will obviously be equal to q by 8 times epsilon naught. This is one way and this is another way. You can use any of the ways. Okay. If I talk about when the charge is placed on one of its sides, so what you need to do, you just need to place a cube over here, right? You have placed a cube and now you can see this charge is completely enclosed. So the entire flux is distributed between 2 cubes. So with one of the cube it will be q by 2 epsilon naught, and this is the method, right? If I talk about this side, so make a cube over here, make a cube over here, make a cube over here. So now this complete edge will be covered and the charge entire flux will be shared by the 4 cubes. So related to one cube, the flux will be obviously q by 4 epsilon naught. So this is one way of remembering and understanding this fact, or else for the other case you can also memorize these fluxes with respect to cubes. Now let's come to the final topic, that is how Gauss law can help us in determining the electric field due to charged bodies. Okay, so let's first take the case of charged spherical shell, and at a point at a field which is more than the radius. So suppose this is a charged spherical shell, this one small radius, this capital radius r, and we need to calculate the value of electric field at this point. So what I am going to do, I am going to draw an imaginary Gaussian surface. So this is an imaginary Gaussian surface, okay, and obviously the electric field lines will obviously radially outward. So E into the small area on the Gaussian surface will also be in outward direction. As I told you, for 3-dimensional bodies the area vector lies in outward direction, and if I talk about this point, then the area vector is like this. If I talk about this point, then the area vector is like this. So E into dA, E vector is obviously having an angle 0. So E dot dA will be equal to E dA into cos of 0, and E has the same magnitude because the distances are same. So E comes out of the integration, and finally it is E into the area of the entire Gaussian surface. That will instead be equal to 4 pi r square. So E into 4 pi r square will be equal to the total charge enclosed within this Gaussian surface, that is Q divided by epsilon naught. Just replace it over here, you will get the value of electric field, and the electric field expression comes in just a fashion like this entire charge is concentrated about its center. Now let us talk about a point inside the shell. So if I draw a Gaussian surface over here, and if I write the expression E dot dA is equal to flux, which is instead equal to Q enclosed upon epsilon naught. So there is no enclosed charge, and hence the flux will be equal to 0, and area cannot be 0, so that means electric field will be 0. So at any point inside a spherical, uniformly spherical charge distributed shell, the electric field will obviously be equivalent to 0, okay. And this was the case also when I had a discussion about why gravity, if you remember the chapter of gravitation, then acceleration due to gravity at any point inside was only depending upon the mass which was inside that point. So we calculated the gravity at depth d, right? So we just considered the mass over here and just neglected this shaded mass, and the reason is this only: the outer charge will have no electric field, and in this case the outer mass will have no gravitational field over here, so no effect on the force, no force, and that is the reason we don't need to calculate it. Now if I draw a graphical representation between electric field and R, so this is the expression from 0 to R, that is inside electric field is 0, and if I move outside, then the electric field turns like this. Now if I talk about a solid sphere, so this is the case of a solid charged sphere. Take it. The earlier case was of charged spherical shell, that is solid shell, a shell, that means there is no matter inside it. So that was an empty sphere, hollow sphere. This is a solid sphere. So charges are distributed all over its volume. So if I talk about any inside point, then using the same concept of Gaussian surface, I can very well calculate the value of electric field, and that turns out to be rho r by 3 epsilon naught, or kq, this is equal to kqr upon capital R cube, okay. So this is the expression when I use Gaussian's law to calculate the electric field at any point inside a solid charged spherical body. If I talk about any point outside, then the same result, this is the charge distributed, I will draw a Gaussian surface, and the case will remain just like the case we did in spherical shell, okay, and the result will turn out to be kq upon r square, similar to what that this entire charge is concentrated about its central point, and the electric field will obviously be equal to kq by r square, okay. Now if I talk about an infinitely line charge, so I had told you very clearly that a finite line charge cannot be discussed using a Gauss law, and infinite line charge can be discussed using the concepts of Gauss law. So as is the case, infinite line charge, and now we need to create what? We need to create a cylindrical Gaussian surface. So this is a cylindrical Gaussian surface, and the electric field lines will obviously be radially outward. So E into the curved surface area, that is 2 pi RL, 2 pi RH, if this is the length L, will be equal to the inside charge will be its linear charge density has been provided, that is lambda. So lambda into L, that will be the inside charge divided by epsilon naught. LL will get cancelled, so E will turn out to be lambda upon 2 pi r epsilon naught. And do remember this expression because it will be used while calculating the value of potential difference as well. So what you need to do, you just need to integrate it with respect to dr and place a minus sign, and in that case you will find the potential difference as well. So we will be discussing about that in the second part. Okay. Now electric field due to a plane sheet of charge. So there is a plane sheet, and if there is a plane non-conducting sheet, that means charges are residing inside it, and over here also we need to create a cylindrical Gaussian surface with its ends, with its circular ends placed like this. So electric field will obviously be towards outward direction if this is an infinitely large sheet. Please remember this thing, the sheet has to be infinitely large, very large. If this is not very large, then the electric fields won't be perpendicular to its surface. They will obviously have a curved pattern. Okay. So for an infinitely large sheet, the electric field turns out to be sigma by 2 epsilon naught. Okay. But now if it turns that it is a conducting sheet, so what happens in a conducting sheet is charges don't reside on its surface, and sigma charge will be on the one side and sigma charge will be on the other side. So sigma distribution, sigma charge density will be on both the sides of a conducting surface, and in that case what happens is the electric field now changes to sigma by epsilon naught over here and over here, and these regions should obviously be very close to the sheet, then only this condition of very large sheet will be maintained. Okay. So this is the expression for electric field due to a plane sheet of charge, and this will be the end of this session. So I suppose we have understood all the concepts. Okay. So you are asking, what if the plane is conducting? So as I told you, if the plane is conducting, what happens is charge sheets gets distributed on both the sides, on the left side and on the right side as well, and in that case the electric field at any point very near to it, it becomes twice, and that is equal to sigma by epsilon naught, and there should be a condition that the charge distribution should be equal on both the sides. So sigma on one side and sigma on other side as well. And if I take the case of non-conducting, then the charges are inside, and obviously I have considered the charge distribution, the superficial, the aerial charge distribution to be sigma. Okay. So this is the difference between both these cases, and I suppose you have got the answer, edu. Okay. Now this is the conceptual knowledge first of all, and we have solved as many questions we could have solved in this limited time frame, but you need to practice more and more questions. And I should be very clear, I have told you with the initial part of the session as well that electrostats plays a major role, and so many questions, you can expect 2, 3 questions or 4 even from this unit of electrostats in JEE Main, and there will be mixture of concepts as well. So in today's topic also, I have tried introducing as many mixture of concepts questions as I could, but still they are very limited, and but you have the access, and you have the access to questions from so many sources, and over here also in the description you will find the link to Extramarks the learning app. You have to download it and you can practice as many questions on electrostats, and trust me guys, those questions are really meant to be in sync with what has been asked from past so many years in JEE Main, even in JEE Advanced. Depending upon your level, you can change the filters and practice some very easy, moderate and even higher or advanced level questions, and even after practicing the questions you can avail the benefits of giving test. Okay. And also during the lecture you have seen this code, right? So do visit our app. In that app you open this test ID option, open test ID option, and just copy this code over there. So what you will get is you will get a free test live in front of you, and you can just give it a try, check the score, analyze the report, the test card, the test ID which you will be getting over there. Based on that you will get a very clear insight what went wrong in that exam and what you need to focus more upon. So this will be the end of the session, and the next session of electrostats, the second part, will be live on 21st Feb. The time remains same, 5 p.m. So do attend that, and before attending this session you should be very clear with your concepts which we have discussed today. So any of your friends visiting or watching this session, you should definitely tell them to visit and to check this entire session of electrostatics part 1 as well, because so many things are interrelated, right? And if I talk about the 12th class, then it is very interrelated. Till the time electromagnetic waves is in the picture, I consider it to be single one unit of electromagnetism. So all the things are interrelated. The capacitance taught over here will be used with resistors and RC circuits will be there. Then these RC circuits along with inductors will be used in alternating currents. Electromagnetic induction is also where you'll get to know about again those resistors, again those changes in magnetic field creating a potential difference. So there are so many interlinking of concepts. So just leaving one topic and going on to the other will not do justice to the topics, and even you will also not get a clear picture about it. Okay, so my personal recommendation to you all is do attend this session of electrostatics part 1. If you have missed it, it is on YouTube. You can view it n number of times as you want, and after this do attend this session as well, because it is going to be very fruitful to you. The next code of this session will be live in this crash course session only, and after watching that you can practice that test as well. So we'll be meeting in the next session. Till then, happy learning, bye bye, all the best to your studies.